Hello, my name is Jake Delgado and I am discussing the process of direct metal laser sintering, or DMLS, for my San Jose State Manufacturing Processes class. DMLS is the process of melting a finely powdered metal layer by layer with a laser to form an object. DMLS begins with a CAD model of the part to be printed, which is sliced into very thin layers and sent to a DMLS printer such as the one shown here. Inside the build chamber of the printer, which is filled with an inert gas to prevent oxidation during the process, each slice is then traced by a high-powered laser that selectively melts the metal powder to solidify that layer. The base plate under the printed part is then lowered slightly in the order of 30 to 60 microns, and the recoater spreads a fresh layer of metal powder over the base plate. The process is repeated for each slice until the complete part is formed. Next, you can see the actual process taking place and the thinness of each printed layer as it is formed and recoated for the next layer. Once the part cools, it is removed, detached from the base plate, and any post-processing operations are performed, such as hole tapping, surface finishing, and heat treating to reduce internal stresses from the forming process. Before any heat treating, the printed metal has already 90% of the strength of the source alloy and can be subject to any of the same post-forming processes. A variety of metals can be used for this process, including alloy steel, stainless steel, aluminum, bronze, and titanium, among others. Some of the advantages of DMLS are the ability to form complex parts that would be impossible to form using machining or casting methods, the wide range of materials that can be used for the process. The parts can be printed directly to metal without additives or binding agents that must be removed in post-processing. The material properties of the printed metals are at better than 90% of the original metal. The prints usually do not require a support structure, and any media that was not sintered in the process can be reloaded into the machine, minimizing waste. Disadvantages of the SMLS process are the high cost of the machine, the powdered metal material itself. Careful control of the process is required to minimize porosity in the finished product. The process is low volume and time consuming, so must be used for small batches. The physical part size is limited to less than a cubic foot. And the machine is complicated to use and requires highly skilled operators. Some of the methods that can be used to maximize process control and get the best print quality requires choosing the correct mix of metals for the desired result and the best design for the part. Optimizing print parameters such as laser speed and media grain size to reduce porosity is important. Optimizing model characteristics to reduce overhangs and sharp edges. Incorporating holes and voids as needed to allow the escape of gases and removal of powder at the end of processing must be considered. And performing post-processing as required to improve surface finish and heat treating to relieve any internal stresses from the forming process can be performed. Thank you for watching.